Welcome to Major Migrations Made Easy. My name is Tim Beek, and I'm a staff software engineer at Moderne, where I work on OpenRewrite. I want to thank you all for coming. You know that you had a lot of good options in this slot, so I appreciate you showing up here. Now, even though this is a presentation on migrations, I am not going to ask you what version of Java or Spring you are using. And that's because it's not an ideal mechanism to get that from you, because by the very definition, you're quite biased since you showed up here. And if I ask you who's using Java 17, then likely some overconfident folk will start raising their hand to say that they're using Java 17, even though they've not yet updated to some of the new language features, and they might have just left the entire company behind on Java 8. So, not going to do that. Since you showed up here, I think it's safe to say you're working with something that you likely want to get rid of. And if you're not comfortable with that, then you can just silently accuse the person next to you of using Java 8 or JUnit 4, which, going by the statistics, is a fairly safe chance. So, before I switched to Moderne, I was a consultant for 5 years, and perhaps much like yourself. I specialized in migration engineering, which is a way of saying I would walk into an organization, familiarize myself with all the old technology that they were still using, and then gradually hack away at lifting everything up to the latest versions. I would frequently find 5 or even 10-year-old versions of Java, JUnit, and Spring, which is not great from a security perspective or even for the developer experience. Initially, I would migrate these services by hand and gradually introduce more and more coarse automation. Because it's boring stuff. You have to rename a method here, change a property there, you have to change a package. You wouldn't want to do this by hand. So imagine my excitement when I discovered OpenRewrite. OpenRewrite promises to make light work of such migrations. I got so excited about this technology that I started to contribute and even present about OpenRewrite, and eventually quit consulting to work on OpenRewrite full-time. So after a nice sabbatical, that brings us here today. And perhaps you face some of the same challenges that I did. At a conference like this, you'll hear everything that's coming up in Java 21 in the fall, and new framework releases. But back at work, you're stuck using Java 8 and JUnit 4. And migrating all of that by hand can seem daunting if it ever gets priority. I want to show you how easy it can be to perform major migrations. That way you too can adopt the latest language and framework features. And it can be fun to pick up new language features such as records and text blocks, but you don't want to adopt these features manually or only on a single project. Instead, we will look into automation to make the old projects feel like new projects again, rather than something that's just had its version number changed. And that way, you can benefit from JVM, language, and framework improvements. Here's a brief overview of the types of migrations I'll be talking about. Likely, you've already performed some of these migrations in the past. And other migrations are always just around the corner. If you look back over time, there's a near constant stream of worthwhile improvements you can pick up. And I like the challenge. I still get excited whenever a new version comes out. I just don't like the repetitive elements that come with upgrading. And if you do try to keep up by hand, you will hardly get anything else done, especially as microservices these days mean that you're not upgrading once, but dozens of times. Over the years, we've seen organizations adopt microservices, which tend to look alike. That can be either by consciously using reference templates, or just copy and pasting from the last service you worked on for any new development. And this can be great for knowledge sharing and reusing shared components, but when a critical issue arises in your technology stack, suddenly everything's on fire. To react quickly, you need a framework that allows you to make broad, sweeping changes at scale. Automation may be the only option, especially for larger organizations maintaining thousands of services. To show you just how easy it is to migrate a project, I've prepared a small demo. For this demo, I will upgrade an old Spring Pet Clinic branch from Spring Boot 2 on Java 8 all the way to Spring Boot 3 on Java 17. And we will look at all the commands and changes made along the way as well. So with that, I do have to switch my screen, which is always a challenge. I didn't pay anything for my operating system, and it does show. Mirror. Looking good, right? We'll power through. That one, cheers. So for this demo, as I said, we'll migrate a Spring Boot application. And for that, I'm going to take you to the documentation that we have on OpenRewrite. Now, if you only remember one thing from this presentation, let it be docs.openrewrite.org, which is the page where we have all the documentation on the recipes that we have available, how you can run them on your own applications, how you can develop your own, and how you can get help if you get stuck along the way. So we're going to look into a migration for Spring Boot, and for that you can either browse through our catalog of recipes, which will give you a quick overview of everything we can cover, but it's just more convenient to use the search. So if you search for Spring Boot, then pretty soon you'll see the migrate to Spring Boot 3.1 pop up. We have a lot of options. We go all the way back to Spring Boot 1.5. And if you want to run this recipe, which will include a lot of steps, which I will go into, then you only have to copy this one command and run this at the root of your project. Now this is for Maven, the instructions, but we also have instructions similarly for Gradle, and there's some more ways of running this as well. But just know, with this one command, you can migrate your application fully. And it includes some more steps, which I'll go into in more detail still. And I've run this demo in the past on my laptop, showing you some terminal, but it's not a great way to show you these changes visually, because someone's going to complain that I'm using a dark font or a dark background. Someone always has their own way. So what I'm going to do instead is I'm going to take you to our platform. So we have a platform that allows you to run these recipes just as well as you could on your own machine, but we allow you to run them quicker, and we give you a preview of the changes rather than modifying the project that you have. So that platform is Moderne, and anything you can see me do here, you can do just as well. And you're able to run some 1,000 recipes against some 35,000 open source projects. So if you want to contribute somewhere, that project is probably already in there. And with these recipes, you're able to make changes if you want to. So as I said, we're going to run a Spring Boot 3 migration. But if you're not a Spring user, it's maybe good to know that there's a lot of elements to a Spring Boot 3 migration that are still going to be useful for you as well. So as part of moving to Spring Boot 3, you need to upgrade to Java 17. You also need to update to Jakarta, and you need to upgrade to JUnit 5. And it's just a lot of these changes that you have to go to the individual migration guides otherwise, and it's just a lot of work. But what we've done here, and you can see it, is that the Spring Boot 3.1 migration first takes you to Spring Boot 3.0. And if we dive into that one, you can see that that in turn first takes you to 2.7. And that way we go all the way back to Spring Boot 1.5, applying any changes along the way. And you don't have to tell us what version you're coming from. We will figure that out. And it's just a really convenient way of doing these large migrations just with a single recipe that you execute, which is composed of further recipes. And we don't just make required changes. So if we look into the Java 17 migrations, for instance, you can see that we change your compiler level to Java 17. But we also update your GitHub actions so that your pull request will actually work the first time around. We also introduce text blocks if you weren't using them before, but only there where it makes sense. And we allow you to switch to the string.formatted, and it's a lot of these small changes that might not be required, but they do make your application feel more recent. And this is just one sample. But there's a lot of more of these types of nice to have changes in there that would otherwise just show up as squiggly lines in your IDE. So to run this migration recipe, I select the Spring Path Clinic project. So I have a repository group here of just the Spring Path Clinic. And what I can show you is that I'm running this recipe both against an old 2.0 branch and against the new main branch, just of the Spring project, which has already been upgraded to 3.1. And if the results work, I can show you exactly why I'm migrating in a project that's already on the latest version. So let's just click Run, and we're going to see how this does. It's always a bit of a challenge for me to do live demos, because you kind of have to hope that things work. And to give you a bit of background, over the past 7 weeks, we've been really working hard on improving the performance of everything we do. So to be able to make these code changes, we have to build up a detailed model of your code that we then run recipes against to modify your source code. And this was working well for small services, but then the guys from Drools showed up, and they had a 200 multi-module Maven project that they want to run recipes against. And we couldn't quite make that work. So we spent the last 7 weeks working really hard to get the performance up to the state where we were able to run for them as well. And I can honestly say after 7 weeks, we've made the performance worse. So things used to work. My demo used to run in 15 seconds. And now it takes 6-7 minutes. So I'm going to switch to the slides and just show you the results that I have for this one before I show you some more. So know that it works normally, but in this case, it's a bit of a challenge. As I said, we're also making optional changes. So this is migrating the Spring Boot 1.5 branch, because it's an old screenshot, because I didn't know I was going to have to reuse my screenshots. But this change, in particular, is also in the main branch of the Spring Path Clinic, which is their reference implementation using Spring Boot 3.1. But they're still using the auto-write on a constructor, and you haven't had to do that for the past 6 years. But it kind of makes sense to apply an automation which will find this and fix it for you. So you don't have to tell it that you might want to run this. We just figure it out for you. Now, another of these optional changes that we do is we figure out that, in this case, you were passing an argument to an annotation. And you probably had to do this in the past. But ever since Java 8, you don't have to do this anymore, because we can figure it out from the compiler parameter arguments. So we remove that, and we do that everywhere we find it. So if you have an old application, and it has a lot of these patterns that were maybe 10 years old, we'll clean that up for you. We'll also take you to the JavaX from the old Hibernate validator, and we also take you to Jakarta. So all of these changes are just really nice to have applied with an automation that you don't have to manually find and fix. So I'm not sure if I have another slide. I do, yeah. So we're not only making code changes, we're also updating your properties files. So Spring, in particular, with Actuator, they have a tendency of renaming properties. And you then have the fun challenge of trying to find them in all your configuration files. And if you're using YAML, you can't even find them with grep. Whereas with this automation, we're able to find all of those and change it, such that you don't have to do this by hand anymore. And let's see, yeah. So this way, we're able to fully migrate your application to the latest version. But we figured, well, if we're able to make code changes and we're able to do these migrations, there's probably some more stuff that we can do for you. And for that, I'm going to take you to a different tab, and that's our common static analysis recipe. So this is a recipe where we've grouped together, let me see if I can go back. Yeah, some of the analysis issues that other tools would pick up for you. So if you're using spot bugs, or you're using maybe old find bugs, or you're using Sonar, Cloud, or you're using any of these scanning tools, then this list of recipe will probably sound familiar. There's a lot of these small improvements that are just on your technical depth backlog in Sonar. And you kind of want to pick this up because it's showing you all these issues on your pull request and in your IDE, but you're never going to go through this and fix 1,000 instances of removing empty blocks across your entire organization. But since we have this automation, we have all of these recipes grouped together into this one big recipe, we're able to run this against 158 repositories in just a couple of seconds. So I pre-created some of these results already, just because of the performance issues that we've been having. And if you zoom out just a bit, is this still readable in the back? Mostly. Then what you can see is that there's a lot of changes that have been applied to these some 158 Netflix and Spring projects. And we can look into the details of just one project where we've applied some of these fixes. And then the results will look kind of familiar to what you know. It's going to be similar to what you have on a Git diff in GitHub, but it's not yet a commit. It's just a preview of the changes we could make. And if you think that they look good, we allow you to create a pull request from the button at the top here. It's taking a bit longer to load than it would normally do, but it does show up eventually. So in this case, we're renaming a variable because it's called sleep interval as if it were a constant, but it's not. And you think, well, that should really be named properly. But if you're ever doubting, well, what are we actually making these changes, we added a button to just give you a bit of background why we're making these changes. And like I said, if you think this looks good, because all of these are tested, they're all very easy changes to make for us, then you can choose to commit these results. And you can either push directly or start a pull request or start a fork and check things out first. Or if you think, well, I'd like to test drive it first, we have a button to just start a CI pipeline, which will also tell you if this is actually working or not. But what you want you to be comfortable with, if you've been doing this for a while, is to go back to that big page of results, select all of this at the same time, and just commit at once. Because if you look at the top, for every small change that we make, we give an estimate of how long we think it will take you in total to make all of these changes. And in just running, in this case, 25 minutes, but trust me, normally 3, we're able to give you some 300 hours of time savings. And I think if you commit this on a Monday, you should get the rest of the week off and just go do something fun. I think this is fun. I think it's for up to 300 hours now. It's so much easier now to apply these fixes broadly across the entire organization, and then you never have to think about these issues again. And we recommend that you run this continuously, so not as a one-off, but continuously, such that when your colleagues check in code that is maybe generated by some automation, that you can actually fix all the issues that might still be in there, such that you just never have to think of this again. Now we have one more recipe, but I don't... Oh yeah, but we have a lot of best practice recipes as well that you can run for just testing practices, logging practices, all of that. But we also have one for vulnerabilities. So again, we have a model of your entire source code across every repository that you have, and we can also find any vulnerabilities in there. So we know your dependencies, we know your transitive dependencies, and we cross-reference them against the GitHub vulnerabilities database. And what we can then do is just, again, apply these fixes broadly. And we'll work out the minimal change that we have to do to fix a version for you. So that can be either inserting, upgrading a property, a version number, or updating a property, or make the necessary code changes to get you to a safer version. Which is, again, I think pretty neat. You should get commendations for applying all these fixes in a couple minutes, so you can actually focus on developing features again. So that's my demo. I think it's pretty neat, but I'll show you how we're actually making these changes by going back to the presentation. One more, no. Oh yeah, one more because it's actually slides now. So let me switch back to just a normal view. New. Just a moment. Because I do like to use a full screen.
You had access to GitHub repos over there. If we have our own Bitbucket server, are you going to explain how?
So what I showed you is the platform, and the platform connects to GitHub, Bitbucket, GitLab Enterprise, Bitbucket Enterprise, anything that you have. But that's the enterprise product. So if you use that, then you can connect to that. But that just depends on what you have. For OpenRewrite itself, we kind of expect that you run this on your local machine. So you won't get the benefits of the platform until you start applying it either on open source projects or you start applying it to your own repositories if you're a customer. That's the thing. We have to make money somehow. So back to the presentation. As we've seen, through OpenRewrite, you can now upgrade between versions of Java and Spring with just a single command. So the Maven command that I showed you works just the same for Gradle. We're working on Bazel. It's just this. You can run it on your own machine if you want. You can also migrate between frameworks. So if you want to move from JUnit to AssertJ, or even if you want to move from Java EE to Spring, then we allow you to do that. In this talk, I'll tell you all about OpenRewrite, so how it came about, how it works, and what you can do with it even more. And finally, we will briefly look at who's developing these recipes and how to apply them to open source projects. OpenRewrite was started in Netflix, initially to aid in the migration of an internal logging framework that they had to SLF4J. And you can probably imagine that any logging framework is going to be pervasive throughout the organization. To even consider migrating, you'd need perfectly accurate automation, especially when usage is spread across hundreds of services. So they developed a parser to accurately read Java and to turn the source code into a lossless semantic tree. And this model is then modified to replace the old logging statements with calls to SLF4J. And next, the migrated model is then written out as close as possible to the original source code. This way, the applied changes are minimal, and we leave surrounding code untouched. Later, the same developers moved on to work on Spinnaker, and while they were trying to onboard teams and organizations there, they found that teams often struggled with the same outdated libraries and frameworks. To help these teams adopt the latest versions, and ultimately Spinnaker, they applied a different set of transformations through this same lossless semantic tree parser. This allowed them to quickly reduce this technical debt, bringing teams from Spring Boot 1 to 2, and from JUnit 4 to JUnit 5. The project has since been open sourced, with the company behind it committed to making all recipes available on the Apache license for open source software. The initial focus for OpenRewrite was on Java virtual machine languages and surrounding technologies. There are parsers for Java, Groovy, Kotlin, YAML, and XML, and they in turn unlock support for build tools, such as Maven and Gradle, and libraries such as JUnit, AssertJ, and Guava. And ultimately, you can refactor entire frameworks and platforms with recipes available for application frameworks, such as Micronaut, Quarkus, and Spring. OpenRewrite is not the only parsable capable of understanding and manipulating Java. There are, however, 3 benefits that you won't get with some of the other implementations. The first is our focus on exact type attribution. By having the exact type available on any tree element, we can be sure to only manipulate exact matches. Other parsers might skip this time-consuming step to get better performance, but then lack the ability to match and apply certain changes. Or even worse, they could give you false positives in their reports, which we really want to avoid. The second characteristic that sets OpenRewrite apart is the format preservation. Our parser not only takes into account the functional code, but also the surrounding code style and indentation. This allows us to accurately reproduce your source file, regardless of any changes. Any changes made through OpenRewrite look just like a colleague worked on your code. And this is different from, for instance, Google's error-prone, which forces you to use their opinionated formatter, which might not be a big deal some of the time, but when you have 20 years worth of Git history, you might not want to reformat everything for a couple small replacements. And finally, our serialization format ensures that you're able to query and refactor your code faster and at scale. And together, these features make OpenRewrite exceptionally good at safe code transformations. The changes are minimally invasive and guaranteed to work, in part due to our do-no-harm mentality. We'd much rather make no change to your code than make the wrong change. We want you to trust the changes that we're making. By manipulating the full lossless semantic tree, OpenRewrite can far exceed simple search and replace operations. Now, with the full lossless semantic tree built, we need to instruct OpenRewrite what operations we want to apply and where to apply them in your code. And recipes are how you define such as group of search and refactoring operations. Together, they accomplish a higher level task, such as a framework migration. Recipes can consist of a single, standalone operation, or be linked together with other recipes. OpenRewrite comes with a large collection of fine-grained recipes out of the box that can be you can then configure to build larger migrations, as you saw me do with the Spring Boot 3 migration. You can think of these as Lego building blocks ready to be applied with the proper parameters. There are hundreds of these building blocks to, for instance, change types, change methods, change arguments, manipulate properties, and alter dependencies and plugins. Individual recipes are implemented as Java visitors that first match and then modify elements of the lossless semantic tree. There are plenty of examples available, but note that you only need a dedicated Java visitor when none of the existing recipes can already achieve your goals. Typically, you can get very far only configuring, combining, and applying existing recipes through a YAML description file. Modules combine and then group together these fine-grained recipes into more coarse-grained application-specific recipes. There are modules, for instance, for logging frameworks, for testing frameworks, and for application frameworks, such as Spring. And you can think of these as Lego sets, with build plans for common migrations and fixes ready to be used. In my opinion, the lossless semantic tree, combined with the large collection of open source recipes, is what sets OpenRewrite apart from other similar tools, such as Google error-prone's Refaster. Now, I want to show you how migration recipes are configured in OpenRewrite. So let's have a brief look at a migration from JUnit 4 to JUnit 5. I want you to imagine what steps would be needed for such a migration. You likely know a couple of these steps already. Among others, you'd have to update the test annotations, but you would also have to update the assertions and sometimes the argument order. You'd have to update all imports, you have to update any test rules, and that's just getting started. Notice how each step is reflected as a separate recipe in this YAML configuration file. Some refer to and configure generic steps, such as the change type recipes. Others are implemented as an imperative step, a dedicated Java visitor that first matches and then modifies elements of the lossless semantic tree. All these steps combine to achieve a complete JUnit 5 migration. And this is a common pattern with OpenRewrite. Large migrations are broken up into small reusable steps. When we run this recipe, we get predictable results. Our imports are converted as we would expect, and our Mockito runner is converted into using the extension. Lifecycle annotations, such as that before, are correctly replaced, but these are just simple replacements. You can see how OpenRewrite shines through when it comes to converting expected exceptions. By having the full power of a lossless semantic tree, combined with a Java visitor, we can now adopt assert throws. And this would certainly not be possible with just a regular expression approach. And it's just a small sample of the types of transformations that are possible through OpenRewrite. Running migration recipes is fairly straightforward. And as you saw in the demo, first you apply a build tool plugin for OpenRewrite. I'm using Maven here, but Gradle works just as well. And then, depending on the changes that you want to make, you add a dependency on the respective OpenRewrite module. In this case, I'm using Spring, but you could also choose those for logging or for testing frameworks, whatever you want. And then, depending on the changes that you want to make, you invoke the recipe that you want to execute here. So, in this case, we have a command to migrate a Spring Boot application to the latest version. And as I said before, it works all the way back to 1.5. Don't tell us what you're using, we will figure it out. It will update dependencies, properties, deprecations from any older versions, and we also include the JUnit 5 migration, as well as any Spring-specific test constructs. So now that we've seen how OpenRewrite works, let's have a look what else you can do with it. Obviously, by now you've seen it is well suited to migrations. You've mostly seen migrations from one version to another, but you can also migrate from one framework to another. So if you want to switch from Log4j to SLF4j, you can. And same thing if you want to switch from JUnit or Hamquest to AssertJ. And even larger migrations are in development. Now, as I showed you in the demo, another application that we have is fixing static analysis findings. We support a large collection of Checkstyle, Sonar, and even security findings to allow you to reduce this technical debt in just a couple minutes. And finally, there's a whole class of recipes to enforce a certain code style. And rather than merely apply a formatter, these style recipes go a step further to actually change your code. And this ensures that your code style reads consistently from project to project. And in addition to what's already available, it's very easy to add custom recipes specific to your projects. So if you have an internal library or framework that you build upon, then you can probably automate those migrations as well, just with a simple YAML description file. So now that we've seen how it works and what it can do, let's have a brief look ahead at what is still to come. As you've seen, we have parsers for multiple languages already, but as you can probably imagine, we do have some catching up to do still. We are further refining our parsers for Java 21 and up and Kotlin. But know that you're perfectly able to run on Java 17+, but you just can't migrate you yet to some of the new language constructs. The interesting thing about Kotlin is that our Java migration recipes will also just work, even though the languages look a bit different. So if you have a project that's using Spring and is using Kotlin or even Groovy, we can migrate that still because we are mapping things to the same model and applying the exact same recipes. And we're testing all of this now with the developers behind the popular Arrow framework for our Kotlin migrations. We're also looking to make it even easier to define migration steps by looking at the approach popularized in Arrow Pro. And while this won't be able to cover all cases, it is convenient when it can. We're also working on a CLI to make it even easier to run migration recipes without having to change your build file. And we're using this to integrate with, for instance, GitHub Actions and GitLab CI to give you feedback and pull requests. We're also branching out into new language families, recently adding Python and TypeScript, and another fun subject that we saw come up this morning is AI. Now, I want to briefly note here that we're not using AI to make these code changes. So if you run things on your machine, nothing leaves your machine, nothing is sent somewhere. We're only applying rules that we've defined before. And that's because we've done tests with AI. And we have, for instance, we have a recipe where you give a prompt and a snippet of code, and it will make that code change for you, which seems practical. But if you run that test 10 times, then it will fail 3 of the 10 times. And that's not really what we want. Our customers are typically large financial organizations, and they like predictability. They don't want a different result tomorrow if you run it again. So we're not using AI to make the code changes, but we are using AI to develop these recipes. So we develop the recipes, and then we test them still in a regular framework that we have. And we are that way able to move fast and cover a lot without making the changes unpredictable in any way. So all these features, they're in active development. It's not clear for some of it when you will be able to use it, but it is interesting developments. And I want to, again, call out here the Refaster templates, because it will make recipe development a whole lot easier. As you can see here, we're defining a before template of the pattern that we want to replace as an annotated method. Then secondly, we define an after template of the pattern that we want to see instead. And these patterns are then matched across your code base and replaced with ease. We like this approach so much that we didn't want to just copy it. Instead, we're going to use exactly these annotations. That allows us to leverage the work from others, such as Picnic, who have defined and open sourced their Refaster templates. Our users then get the benefit of applying Refaster templates at scale without the Google Java format enforced by ErrorProne. And if you need more than ErrorProne can support, then we allow you to gradually switch to OpenRewrite recipes. Now, as a last subject, I want to tell you a bit about the company behind OpenRewrite. As I said before, Moderne has committed to making all recipes available under the Apache license for open source software. You can run OpenRewrite on your own machine against any project that you want, including private code. It will work, but it won't be quick, and it will only update one project at a time. It won't make any pull requests, you have to do some of the plumbing yourself, but it will just work. With Moderne, our focus is on applying recipes at scale. Through Moderne, our clients can discover code patterns across an entire organization and target these for transformation. And even if you're not a paying customer, you can still use our web interface to browse available recipes and even apply them to open source projects. And this can be a great way to start contributing back to open source software. And if you find that any migration recipes are missing, OpenRewrite itself is very accepting of new contributions. The community plays a large role in the development of new recipes. And as you could maybe tell from my email address, we're not exactly a big company. It's just tim@moderne.io. But we're pretty well connected into the broader Java community. Through collaborations, other companies contribute migration recipes for their frameworks. And these then ensure that their users are able to migrate easily and timely with new releases. And if you maintain or merely enjoy your particular library or framework, you can help all other users by providing migration recipes. And this is something that I do on the weekends for Apache Maven, just for fun. So, as you can probably imagine, Apache Maven has a pretty rich history. They've been going for 15 years, and by now they've amassed some patterns that they're not quite pleased with. They really smell like Java 5, Java 6, Java 7, and they have some things that they want to migrate away from. Now, one of these is that they they created a ticket a couple years ago where they're using 4 different versions of a Commons Lang or Plexus utils and different dependencies, which all together add some 2 megabytes to the Apache Maven runtime. And if you look at what are you actually doing, they're checking if a string is empty or not, which is not really something that you need 2 megabytes of dependencies for. But it's fully volunteer-driven, and no one in their right mind is going to go through all these 90 repositories that they have to do these types of replacements. But as you could see with the recipes that we have, especially with the Refaster template, we can quite easily say, well, don't call this one utility method, but just use the JDK. Is this string null? Is it empty? Then it's true. Then we're able to run these transformations quite easily. And I've been quite lucky that I had someone who's a Maven contributor be prepared to actually do the code reviews on all of these small individual pull requests that I'm creating. I think he's pretty foolish because I'm going to do a couple hundred more, but he's so very kind in reviewing all of this. The only bit of pushback that luckily I was able to counter is that we had one of the Apache Maven contributors ask if I would be able to create a Jira ticket for every pull request that I opened. And if you're doing hundreds, then I'm just glad I was able to push back on that. So we're not going to do that. But it is a fun case. It's fun to use these tools, develop these recipes, and then after I've made them, everyone can run those same recipes for their projects as well. And so with that, we're going to wrap up. Before I send you on your way, I want to recommend a few resources where you can learn more. Firstly, there's extensive documentation and tutorials available on OpenRewrite. And that's again at docs.openrewrite.org. Our development is all on GitHub, with new suggestions picked up with surprising speed. And as you've already seen, it's quite easy to contribute minor migration steps for frameworks. If you want to try some recipes quickly on open source projects, have a look at app.moderne.io. That's everything I showed you in the demo. You can do as well. You can help out with the Apache Maven migrations. And if you have any questions, you can reach out either through our public Slack or via email. And if you would like to play around with these commands that I showed you in the demo on your local machine, I've written a blog post to accompany this presentation. It is a bit dated. I wrote it a year ago, and there's new versions of Spring Boot and everything out. But it does allow you to migrate a pet clinic branch from Spring Boot 1.5 on Java 8 all the way up to now 3.1 on Java 17. And you can see the changes that it will make at every step. For your own projects, I recommend you start with our testing framework migrations. They are an easy way to gain confidence in the tool and see what it can do for your projects as well. And since you have test coverage, you're going to be pretty confident that it will work. And with that, I would like to thank you all for your attention.